If you've been following SpaceX content for a while, you've probably heard of Tim Dodd, better known as the everyday astronaut. He's a popular science communicator who's visited Starbase many times and even sat down with Elon Musk for in-depth conversations about Starship. Recently, Tim has stirred up the community with a bold claim. NASA's Artemis mission is overly complicated and simply not practical. Instead, he put forward a daring idea for how humans could return to the moon with something he calls a Stubby Starship, essentially a scaled-down version of the HLS lander. So, what exactly is this plan, and could it really work? Let's find out in today's episode of Alpha Tech. Beyond Tim Dodd, many others also agree that Artemis, the mission meant to return humans to the moon, for the first time in this century, specifically Artemis 3, is incredibly complicated. That's because the mission requires the coordination of multiple spacecraft. NASA's SLS rocket will launch the Orion capsule to the near rectilinear halo orbit, while SpaceX's Starship HLS is needed to carry astronauts down to the lunar surface and back up again. On top of that, numerous tanker starships must refuel the HLS in Earth orbit before it can even begin its journey. The process involves a long chain of critical steps: launches, dockings, orbital refueling, executing the translunar injection burn, a rocket burn to send the spacecraft from Earth to the moon, and precise navigation in deep space. And it doesn't stop there. The current HLS design requires carrying massive amounts of propellant, along with additional fuel tanks just for the TLI maneuver, adding more mass and lowering efficiency. Meanwhile, challenges like propellant boil-off during orbital refueling and the delicate crew transfer from Orion to HLS in lunar orbit all pile up, pushing the risk of failure even higher. That's exactly why Tim Dodd has put forward an idea that's far simpler and potentially much more efficient. Specifically, instead of relying on the massive Starship HLS, which needs between 1,200 and 1,600 tons of propellant after a complex refueling campaign, Tim suggests using a Stubby Starship. This smaller variant would carry only about 400 tons of propellant, feature a shorter body, and eliminate 20 to 25 tons of mass from stainless steel fuel tank walls and structural components. By eliminating the massive tanks and hardware required for TLI, the dry mass of the lander is significantly reduced, and that creates a whole chain of benefits. The vehicle becomes shorter, with a lower center of gravity, making it more stable during landing, while also simplifying systems like the crew elevator. On top of that, the compact design makes the Stubby HLS safer, since it retains up to 700 meters per second of delta VA margin when traveling from lunar orbit down to the surface and back up again. Think of it like driving a car. You need enough gas to reach your destination, but having extra in the tank gives you flexibility. With just 400 tons of propellant, the Stubby Starship has enough to complete its mission and still keep a healthy reserve. That extra capacity could prove critical. It allows the lander to handle unexpected issues like diverting around hazardous terrain, circling for a better landing site, or correcting its trajectory if something goes off course. Because the vehicle is lighter, it burns less fuel while still delivering the same performance, leaving more in reserve for safety. Most importantly, it wouldn't require dozens of Starship tanker flights. Just 2 or 3 would be enough. But why would 400 tons of propellant be enough to get the job done? Here's the key point. Tim argues that the HLS shouldn't perform its own translunar injection burn. Instead, a dedicated translunar tug or a translunar depot would handle the TLI, pushing the Stubby Starship from Earth orbit into the near rectilinear halo orbit around the moon. However, this idea also comes with several challenges. First, in order to perform the TLI burn, the Stubby HLS would need to dock nose-to-nose with either the tug or the depot, and then both vehicles would have to fire their engines together for several minutes. That's something that has never been done before. It would require an extremely strong docking interface to handle the thrust forces, along with ultra-precise software to keep both spacecraft perfectly stable. Second, the depot itself, the so-called translunar depot, would have to be launched into Earth orbit. Because it's designed to be lightweight and only equipped with 2 Raptor vacuum engines, it can't carry a full load of propellant when launched. In fact, to burn through 1,600 tons of propellant, those 2 engines would need nearly 19 minutes. That means the depot can only launch with less than 600 tons on board. In other words, You'd have to dedicate a booster just to get the depot into orbit. But then again, that's a challenge faced by the full HLS design too, not just the Stubby version. Finally, this approach increases mission complexity since it now requires coordinating two large spacecraft, the Stubby HLS and the Tug, or Depot, instead of just one. Both would need to be launched, refueled, docked, and operated in perfect sync to successfully perform the TLI. Still, Tim Dodd believes the potential benefits make it worth pursuing. He emphasizes that the full-scale HLS, performing its own TLI, leaves almost no delta-V margin, making it vulnerable to issues like propellant boil-off or navigation errors, and ultimately increasing mission risk. By contrast, the Stubby HLS reduces dry mass by eliminating the giant TLI propellant section, requiring only about 400 tons of fuel while leaving nearly 700 meters per second of delta-V in reserve. It also cuts down the number of tanker flights needed, while still preserving the full crew and cargo volume, meaning SpaceX could meet NASA's contractual requirements without penalty. Yes, this approach does demand a nose-to-nose docking with a translunar tug or depot, and the docking structure must withstand the thrust of a TLI burn. But the numbers actually work in its favor, with two Raptor vacuum engines producing 1,870 tons of thrust. Acceleration would range from just 0.3 g at the start of the burn to about 0.78 grams at the end. SpaceX could throttle down to avoid the peak, and designing a structure to handle loads under 0.78 g is well within reach. Looking ahead, the Stubby HLS could also play a crucial role in situ resource utilization, producing and loading propellant directly on the lunar surface. Future missions will eventually need to refuel on site, and that's where size matters. With the standard HLS holding over 1,000 tons of propellant, extracting and filling that much fuel from lunar regolith could take years. But with the Stubby HLS, the smaller 400-ton capacity makes the process far more manageable, cutting down the time and effort required, and ultimately boosting the efficiency of Starship's long-term lunar operations. All of this, Tim argues, makes the Stubby HLS not only feasible, but potentially the smarter solution. So, what do you think? Is Tim's plan really a better alternative to NASA's current Artemis architecture? Let me know your thoughts in the comments below. Honestly, when I first heard about the idea of a Stubby HLS, it instantly reminded me of Dr. Robert Zubrin's concept of a mini Starship. But unlike the HLS, his idea wasn't for the moon, it was for Mars. Zubrin, an American aerospace engineer and one of the biggest inspirations behind Elon Musk's Mars dream, laid out a pretty bold plan. Here's how his plan would work. A full-size Starship would launch the mini Starship into a high Earth orbit, close to escape velocity. From there, the mini Starship would continue its journey to Mars on its own, while the main Starship would return to Earth, refuel, and prepare to launch another mini Starship, almost like a reusable space shuttle bus system. Compared to the full-size Starship, the mini version would require only about 1/5 of the propellant, yet still carry roughly 1/3 of the payload or crew, enough for early exploration missions. More importantly, it would need far less fuel for the return trip, drastically reducing the burden of producing propellant on Mars. According to Zubrin, this approach would allow SpaceX to reuse its main Starship much more frequently without leaving them stuck on Mars for hundreds of days. That means faster turnaround times and more missions in a shorter period. Sure, it wouldn't be carrying 100 people like Elon Musk's original vision, but for the very first missions, that scale just isn't necessary. After all, finding 100 volunteers willing to leave Earth and head to a completely uncharted world, that might be an even bigger challenge than building the rocket itself. But something tells me quite a few of you watching would be up for it, right? So here's how the plan actually works. 4 spacecraft are involved in the mission, and get this. Even if 3 out of the 4 fail, the crew can still make it home alive. Pretty wild, right? It all kicks off with the first 2 ships. One's a full-sized uncrewed Starship called A, and the other is a smaller mini Starship called B. Both of them head out during the very first launch window. Ship A is basically the fuel factory. It's packed with a CO2 collector, water, and CO2 electrolysis systems, solar-powered rovers, a Sabatier reactor, and big hydrogen tanks. And here's the clever part. If they can't pull water out of the Martian ground, A can still make fuel just by mixing Martian CO2 with the hydrogen it brought along. That's already enough to get Mini A back to Earth in one piece. Solar panels power the whole operation, no matter which process ends up working. Meanwhile, Ship B doesn't have a crew on the way out, but it's fully decked out for humans to live in. Inside, it's got life support, 2 years' worth of food and supplies, recycling systems for water and waste, roomy living space, and all the basics astronauts are going to need. On top of that, it carries 2 backup CO, 2 electrolysis units for making oxygen, plus a rover so they can start exploring the Martian surface right away. About 2 years later, when the next launch window opens, assuming everything's gone to plan so far, Ship D arrives. And this one's the big moment. It's the first crewed spacecraft. On board are the astronauts themselves, ready to kick off the science, plant the flag, and most importantly, deploy a fuel-hauling rover. That rover's job is simple but critical. Move propellant from Ship A over to both D and B, just in case it's needed. And then comes the final ship, Ship C, a full-sized cargo Starship. This one brings the heavy-duty gear, ice mining equipment, a large pressurized rover for long-distance exploration, and the very first components of a long-term Mars habitat. If all goes well, this setup could let the crew travel hundreds of kilometers from their landing site and stay on Mars for much longer stretches. After that, it's all about scaling up. We can start sending in more Starships, hauling hundreds of tons of supplies to build out a proper Mars base, and do it way faster than most people think. Thanks to 4 reusable launch pads that don't need long maintenance between flights, these Starships could be blasting off just hours apart. And honestly, that might be the most efficient way to establish a lasting human presence on Mars. Because at the end of the day, if our goal is to take that first real step toward a permanent Martian colony, a safe, low-risk first step, then the Mars mission might just be one of the best approaches we've got. All in all, whether it's the Stubby HLS or the mini Starship, these concepts push SpaceX a step closer to making the Moon and Mars dream a reality. They also help strengthen the community of rocket enthusiasts who live and breathe this stuff. Hopefully, we'll get to see SpaceX turn these ideas into success sooner rather than later. There's been a lot of talk about Artemis and America's return to the Moon, but not everyone in Washington sees eye to eye. One example of this disagreement came recently during a public hearing when former NASA Administrator Jim Bridenstine warned that with NASA's current approach, especially the heavy reliance on SpaceX's still untested Starship, it could be very difficult for the U.S. to beat China back to the Moon. NASA's acting administrator, Sean Duffy, didn't take that lightly. He pushed back, calling Bridenstine's comments misleading and harmful, especially at a time when the U.S. is trying to coordinate with partners and stay ahead of China's rapid progress. On a podcast hosted by NASA Public Affairs Officer Gary Jordan, Duffy explained what worries him most. And surprisingly, it's not SpaceX, it's NASA itself.
Here is my one concern. If Artemis 1, Artemis 2, and Artemis 3 are all $4 billion a launch, $4 billion a launch. At $4 billion a launch, you don't have a moon program. I don't think that exists. We have to bring the price down.
And that's the heart of the issue. Each Artemis mission comes with a price tag of about $4.2 billion, and most of that cost comes from NASA's SLS rocket. It's so expensive that building any kind of long-term moon program around it becomes nearly impossible to sustain. Congress seems to be paying attention. In its proposed 2026 budget, the House has actually told NASA to rethink the Exploration Upper Stage, or EUS. Why? Because it's become a bottleneck, years behind schedule, massively over budget, and offering almost no real performance boost over the current setup. Lawmakers now want NASA to look at cheaper, faster alternatives that can still deliver at least 130 tons to low Earth orbit. This is no small directive. The EUS is the upper stage designed for the SLS Block 1B and Block 2 configurations, meant to replace the interim cryogenic stage used on Block 1. Powered by 4 RL-10 C-3 engines running on liquid oxygen and liquid hydrogen, it's supposed to give SLS the extra push it needs for trans-lunar missions. But the problem is clear. Despite its promise, the EUS is years behind schedule and massively over budget. That's why Congress now wants NASA to lay out, within 180 days of the law's passage, how it plans to either fix EUS or pursue alternatives that can actually deliver on time and on budget. The first flight of the EUS is planned for Artemis 4 in 2028, but the EUS has become an expensive and delayed part of the program. According to NASA's Office of Inspector General, its development costs have jumped from an initial estimate of $962 million to $2.8 billion, while the schedule has slipped by more than 6 years. In theory, canceling or replacing the EUS could save NASA a significant amount of money. However, going back to the temporary ICPS stage isn't really a feasible option either. So, what options does NASA have? One proposed alternative is to use a commercial upper stage that runs on the same liquid hydrogen and oxygen fuel and is roughly the same size as the EUS. That brings us to Blue Origin's New Glenn upper stage, which is powered by 2 BE-3U engines optimized for vacuum. The second stage of New Glenn, called GS2, was designed to run on liquid hydrogen and oxygen, just like the EUS. In theory, integrating it with SLS would only require a structural adapter to connect it to the SLS core stage and interface with the payload. But NASA has flagged a few concerns. A major one is physical constraints. The combined height of the SLS core and Blue Origin's upper stage would exceed the maximum height of the Vehicle Assembly Building at Kennedy Space Center. Adjusting for this would require costly and time-consuming modifications to the VAB structure. NASA also noted that the BE-3U engines produce higher thrust than the RL-10 engines originally planned for EUS. That means higher acceleration at the end of the upper stage burn for the Orion spacecraft, which could stress its structure and even require redesigning the solar panels to handle the extra force. Another option on the table is using the Centaur 5 upper stage, which has similar technology. Of course, this would also require modifying the SLS core and launch tower to accommodate Centaur 5. Even though no alternative completely solves Artemis's challenges, they could at least make the journey to the moon a bit easier. Now, let's say NASA does manage to bring costs down, maybe around $2 to $3 billion per mission. What's the next step if they want to land astronauts on the moon before China? The answer is obvious: speed up Artemis 2 and 3. So far within the Artemis program, NASA has only completed Artemis 1, an uncrewed test flight. And that mission revealed some issues that could directly affect astronaut safety. Specifically, Orion's heat shield, made from AvCoat, experienced unexpected erosion during re-entry. More than 100 spots lost material faster than expected, leaving behind small holes and cracks. This happened because Orion slammed back into Earth's atmosphere from lunar orbit at nearly 40,000 kilometers per hour, under extreme heat and pressure. Thankfully, the spacecraft's internal structure wasn't compromised, and the SLS rocket itself performed quite reliably. NASA has since announced that they've developed a stronger material for Orion's heat shield, and will see those improvements put to the test on Artemis 2, which is now officially scheduled for April 2026, a timeline they confirmed at the end of last year after pushing the mission back from the original target of September 2025. That delay was mainly because of safety concerns raised during Artemis 1, things like the unusual erosion on Orion's heat shield, and some issues with the life support system. Thankfully, as I mentioned earlier, those problems have already been addressed. Preparation is moving steadily. Rocket stacking actually began on November 20th, 2024, at Kennedy Space Center. The giant SLS core stage had already been delivered in July, and the adapters needed to piece the entire rocket together arrived in September. Orion also had to undergo a key fix when engineers discovered a leaky oxygen valve on engine E2063 in April 2025. That engine has since been swapped out with a different unit, E2061. Now, NASA is aiming to roll the fully integrated SLS out to Launch Pad 39B by the end of this year, with system checkouts already underway. At the same time, NASA is also ramping up its public presence. Later this month, at Johnson Space Center in Houston, they'll host a multi-day media event starting on September 22nd with the ceremony to introduce a brand new astronaut class, followed on the 23rd by a full science and technology briefing for Artemis 2. And here's the part that really shows how bold they're being. For the first time in more than 50 years, a crew will be heading to the moon, and your name could literally fly with them. Through a campaign called Send Your Name, anyone can submit their name online in English or Spanish, and it will be stored on a digital SD card carried aboard Orion when it takes 4 astronauts on a journey around the moon. It's a massive PR move, but more than that, it's NASA sending a clear signal to the world. America intends to win this new race to the moon, but no matter how you look at it, running an Artemis mission is still insanely expensive. We're not talking hundreds of millions. It's in the billions every single time. And remember, a lunar mission like Artemis 3 isn't just about one rocket. It requires an entire fleet working together. Starship tankers, the Human Landing System, NASA's massive SLS, and the Orion capsule. Which makes you wonder, why not just stick with SpaceX's system alone? Actually, Elon Musk revealed this plan back at the 2017 International Astronautical Congress, before Starship even existed. What's interesting is that this plan didn't rely on NASA's SLS rocket or Orion spacecraft. It was a completely independent concept, based on what we now know as Starship. The original SpaceX vision imagined sending 100 people, or 100 tons of cargo, to the moon, far beyond what NASA's Artemis missions require. Sure, each Artemis mission might need dozens or more of Starship launches to refuel in orbit, which adds complexity and cost. But that complexity was already accounted for in SpaceX's plan. On the flip side, Starship is fully reusable, more powerful, and capable of carrying much heavier payloads than SLS. It can fly more frequently and even land directly on the moon or Mars, something SLS and Orion can't do. It's also much simpler than NASA's current approach. Only a single crewed vehicle is needed, eliminating the need for complex rendezvous and connections in lunar orbit. In this concept, a crewed Starship would be refueled in an elliptical Earth orbit, then fly straight to the moon, land on the surface, and bring astronauts back safely to Earth. It would re-enter the atmosphere using a heat shield and aerodynamic flaps, then land vertically back on Earth. This version of Starship is designed for complete end-to-end lunar missions, including re-entry and landing. That's very different from the Starship HLS variant that NASA chose for Artemis. Unlike the reusable Starship, HLS is not meant to return to Earth, so it has some major differences. Since it will never return, it doesn't need a heat shield or aerodynamic control surfaces. Instead, it features 5 solar panels that deploy from the midsection and a special white thermal coating to prevent the sun from heating its cryogenic fuel. Overall, the idea of using a single Starship for the entire journey to the moon and back is still probably years away from becoming reality. One of the main challenges is safety. Unlike SLS and Orion, which proved their reliability on their very first mission, Artemis 1, the HLS variant hasn't even been fully unveiled or tested yet. To compensate for this, Starship would need to demonstrate extremely high reliability. NASA might even require dozens of consecutive successful flights before astronauts are allowed on board. It's a high standard, but given the potential, it could be worth the wait. The benefit of having a fully reusable vehicle capable of carrying astronauts to the moon and back is simply too big to ignore. If Starship proves itself, it could revolutionize lunar exploration, making it far more cost-effective, frequent, and sustainable. Someone who is labeled as crazy often turns out to be a true genius. Take Nikola Tesla, for example. Many of his contemporaries dismissed him as a mad scientist for daring to propose alternating current, radio waves, and even wireless power transmission. Yet today, those very ideas power and connect much of our modern world. Or consider Konstantin Tsiolkovsky, the Russian scientist who developed the fundamental equations of rocketry and first proposed using liquid-fueled rockets to reach space. At the time, people thought his ideas were absurd and impossible, but his theories laid the very foundation of modern space exploration. And now, when Elon Musk talks about building outposts on the moon and even on Mars, many people also think he's gone crazy, or joke that he's simply trying to find his way back to his home planet. But believe it or not, Musk is actually drawing up a plan for a permanent base, a place where people can live, work, and do research right there on the moon's surface. And yeah, it even has a name, Moonbase Alpha. Now here's the twist. That idea pretty much wrecked China's big lunar ambitions. See, At the end of 2024, during a deep space conference in Anhui Province, China announced they'd team up with Russia to build something called the International Lunar Research Station. Sounds impressive, right? Well, not so fast, because here's the reality. Neither China nor Russia has a rocket anywhere near powerful enough to haul hundreds of tons of stuff, materials, machinery, life support gear to the moon. The only thing they've got is Lanyu, a lunar lander built by CNSA, and it can only put down about 26 tons and support astronauts for maybe a few days, at best a week. Meanwhile, Musk's Moonbase Alpha is based on an entire fleet of Starships. We're talking the HLS variant with a massive pressurized volume of about 1,000 cubic meters, enough for up to 100 people. Plus, you've got cargo starships that can drop 100 tons of supplies directly onto the lunar surface. So, when you put the two side by side, yeah, they're already overshadowed, maybe even straight up crushed by SpaceX. So, here's the detailed plan. Somewhere around 2030 to 2035, once SpaceX's orbital refilling system is fully up and running, and both the lunar lander and cargo Starship versions are working smoothly, that's when things really kick off. First, they'll send down an uncrewed cargo Starship to scout the landing site, make sure the terrain is safe, and test that the landing legs can actually hold steady. Because, let's be real, with a 52-meter tall rocket, sticking the landing on the moon is no small feat. Once that's confirmed, a crewed HLS Starship will touch down. And after the site is stable, the rest of the cargo Starships will start landing one after another, bringing the supplies needed to start building out the base. Of course, those Starships can't just land right next to each other. They'd need to be spaced at least 60 meters apart, because later on, astronauts will actually tip them over into a horizontal position to fit the layout of Moonbase Alpha. And here's the genius part. Because of Starship's long cylindrical shape and its wide internal volume, each one can be repurposed as a ready-made module. Once it's lying on its side, a Starship could become a living quarter, a lab, a storage room, even bathrooms and sleeping areas, all seamlessly integrated into the larger Moonbase Alpha network. This approach saves a ton of time and resources, since you don't have to build brand new structures from scratch. I mean, think about it. Climbing up and down a 52-meter rocket ladder every day would get pretty inconvenient, right? Horizontally placed Starships also make it way easier to access the interior through side doors or reworked hatches, creating a connected modular layout across the whole base. And the smartest way to tip a Starship over? Inflatable airbags. You simply deploy and inflate them, retract the landing legs, and let the vehicle settle safely into a horizontal position, without risking cracks or explosions. Oh, and one thing to note, the HLS crewed lander will remain upright, since that's the vehicle astronauts will eventually use to return to Earth. After that, the most complicated phase begins, transforming the interior. Since most of Starship's structure is just propellant tanks, engineers would first need to drain any leftover fuel. Then comes the hard part, cutting out sections of the tanks to rebuild the inside, turning it into something closer to a mobile home. But if Starship is going to serve as a long-term lunar RV park, its interior will need a complete overhaul, shifting from a transport vehicle into a permanent living space. So, what does a real home need? First, floors and walls to divide up rooms. Then, wiring, ventilation, communications, lighting, thermal control, plumbing with water tanks, bathrooms, showers, and, of course, furniture. The goal is to keep the layout simple yet effective, maximizing both comfort and practicality. Inside, Starship will likely follow an open-plan design with a single deck stretching from front to back, about 1/3 of the rocket's circumference. This setup allows storage and equipment to be placed beneath the floor, while leaving enough overhead room to keep the crew from feeling cramped. The length of the ship could then be divided into different zones for essential functions: living quarters, dining, science labs, exercise space, and maintenance workstations. The living quarters would focus on privacy, comfort, and rest for each astronaut. Sleeping areas might take the form of modular pods or small rooms designed to reduce noise, control lighting, and help maintain healthy circadian rhythms, despite the moon's unusual day-night cycles. Shared dining and social spaces are just as important, supporting morale and mental health. These would include a kitchen or food prep area, storage for supplies, water recycling systems, and areas for relaxation, gaming, or virtual communication with Earth. Meanwhile, dedicated science labs would handle tasks like analyzing lunar rock samples, conducting biological experiments such as growing plants, and performing technical work vital for sustaining lunar operations. Exercise equipment would also be essential to counter the effects of low gravity, like muscle weakening and bone loss. And finally, workstations could include robotic control hubs for operating construction and repair equipment remotely, crucial for keeping the habitat running. But of course, before any of that, we'd first need to take care of the astronauts' most basic health needs, right? First, let's talk about temperature. At the lunar South Pole, things get extreme. Inside the permanently shadowed regions like Shackleton or de Gerlache craters, the temperature never rises above darkness, dropping to an almost unimaginable minus 230 to minus 280 degrees Celsius. Yet, just a short distance away, along sunlit peaks like Malapert Massif, temperatures can swing to a blistering 100 degrees Celsius in lunar daytime. That kind of environment is brutal for astronauts, threatening thermal shock and serious cardiovascular stress. To fight back, engineers plan to use local regolith as a shield, piling or 3D printing it into 50 to 100 centimeter thick walls and roofs around the horizontally landed Starship modules. This natural insulation would smooth out those wild temperature swings, keeping both astronauts and equipment safe. But even then, a robust climate control system is absolutely critical, as essential as oxygen itself. If the cooling or heating cuts out, it's instantly life-threatening. And of course, astronauts will rely heavily on EVA suits whenever stepping outside, not just for mobility, but also for regulating their body temperature in this unforgiving world. And speaking of spacesuits, it's not just about temperature, they also have to protect astronauts from deadly lunar dust. Why? Because those tiny particles are sharp, clingy, and everywhere. Apollo astronauts said it smelled like burnt gunpowder and stuck to everything, even getting inside the lander. Once it floated around, it irritated their eyes, throats, and lungs. Long term, it could be really dangerous. That's why future suits will need anti-dust coatings. And before stepping back into a habitat or Starship module, astronauts would pass through dust removal chambers, blasting the particles off with air, sound, or electromagnetic fields. Next up are water and oxygen, the most critical needs for survival. Sure, astronauts can bring along tens of thousands of liters of water, but eventually that supply runs out. And sending more from Earth is insanely expensive. Even with Starship, it's about $1 million per ton. That's why local extraction becomes the priority. At the lunar South Pole, there's plenty of frozen water ice. NASA's 2009 LCROSS mission already confirmed its presence. The idea is to scoop up the icy regolith, heat it in thermal extraction units to around 100 degrees Celsius, turn it into vapor, then condense it back into liquid water. Oxygen, surprisingly easy. Lunar soil is basically a gold mine. It's about 40 to 45% oxygen by mass. All you need is to heat it up in molten salts like calcium chloride, around 900 degrees Celsius, and you can pull oxygen gas right out of the metal oxides. That oxygen goes into storage tanks for breathing, while the leftover metals like iron and titanium can actually be recycled into building materials with 3D printers. NASA already tested this back in 2023, and the results were huge. 1 ton of lunar dirt can produce 10 to 20 kilograms of oxygen. That's enough to keep a single astronaut alive for almost 2 weeks, maybe even longer. Now, food is a little trickier. At first, astronauts will lean on pre-packaged meals, dried meat, cereals, soups, and high-energy nutrition bars. Nothing fancy, but proven on the ISS, and the best part, they last 2 to 3 years without spoiling. But to keep things balanced, they'll also need some fresh greens. That's where a lunar greenhouse comes in. Instead of soil, they'd use hydroponics, plants growing in nutrient-rich water solutions with nitrogen, phosphorus, potassium, and all the essentials. Way more efficient, and no risk of regolith dust getting into your salad. Special red and blue LED lights, the exact sweet spots for photosynthesis, would keep the plants growing strong, while automatic controls adjust the cycle to mimic day and night. And the best candidate? Lettuce. It grows fast, just 30 to 40 days, barely needs water, and it's packed with vitamins A, C, and K. Plus, it's already been successfully grown on the ISS. Spinach and radishes are solid contenders too. At the end of the day, Moonbase Alpha isn't just about surviving on the moon. It's about proving that humanity can take its first real step beyond Earth. And once we do that, Mars and the rest of the solar system suddenly don't feel so far away. On September 8th, Elon Musk posted a short, 4-word message on X. "You'll thank me later." Simple as it was, the post sparked a ton of curiosity, with many speculating it hinted at a secret project from SpaceX or even Tesla. Then, on September 16th, Musk clarified things in a reply on X, revealing that it was actually the name of a new cargo ship. He said, "Watership to transport spaceship from Starbase to Cape Canaveral." So, it's now clear. "You'll thank me later" is the full name of the watership, and it's designed to carry starships from Starbase, Texas to Cape Canaveral, Florida, specifically to LC-39A, where SpaceX is building a new launch pad and a massive gigabay for Starship production and launches. Honestly, this will be the 4th ship Musk has given a uniquely memorable name. The previous 3, used for Falcon 9 transport and landings, are a shortfall of gravitas, just read the instructions, and, of course, I still love you. All 4 draw inspiration from the sci-fi novel series The Culture by the late Iain M. Banks, partly as a tribute and partly to create something completely unique and unconstrained, just like Musk himself. And get this, just a few days before Musk's mysterious post, SpaceX actually launched this very ship, sometime in early September. It's registered under the number 308 and is currently in its testing phase, with all sightings tracked by the automatic identification system near Starbase. Here's the cool part. The deck of this ship is huge, roughly 300 feet long and 100 feet wide, about 91 by 30 meters. That's more than enough space to carry the big Starship pieces, like the main ship and the booster. Both are 9 meters in diameter, so they can be transported standing up or lying down without any problem. The watership was likely built at a shipyard in Louisiana or Texas, not far from Starbase. Right now, it's still not fully finished. SpaceX is probably testing balance, checking for leaks, and running automated control systems. The full setup should be ready in about 2 to 3 months, maybe by mid-December. But here's the question. Why does SpaceX even need to move Starship from Texas to Florida? A lot of you probably already know the reason. As I mentioned earlier in this video, at LC-39A near Kennedy Space Center, SpaceX is building another launch pad, and it's almost finished. In fact, just last week, SpaceX lifted and installed 3 legs of the orbital launch mount right next to the tower. The whole job only took a few days. Horizontal fuel tanks are also being set up, and the entire system should be ready for testing and final integration before 2026. The Starship production site, the so-called Gigabay, is a different story though. According to the FAA proposed case, construction officially started in April 2025. By mid-April, satellite images already showed rapid site prep, upgrades to the current operations center, and temporary tents going up. But the filings also make it clear, full construction won't be finished until August 2026. Fast forward 5 months, and Gigabay is still in its early development phase, with work focused mainly on excavation and piling installation. So, yes, August 2026 is the target for completion, but even then, it's not guaranteed. Given the massive scale of this factory, it's more realistic to expect operations to begin in 2027. That means the launch pad at LC-39A could be up and running for over a year without any Starships being produced on site, which is exactly why SpaceX needs to transport them all the way from Starbase, Texas. In that case, you'll thank me later, we'll have to work full-time. The FAA has already given SpaceX the green light to launch up to 44 Starship Super Heavy missions per year from LC-39A at Kennedy Space Center, Florida. This approval comes from the Environmental Impact Statement released in late August 2025, which covers launches and landings both at LC-39A and offshore drone ships. Public hearings are running until September 22nd, with final approval expected before the end of 2025. If everything goes through, we could see the very first Starship flight from Florida by the end of this year. And that means SpaceX will need to ferry at least 1 Starship and 1 Super Heavy across the Gulf every single month, maybe even less often, since moving them is such a massive effort. The process starts right at Starbase's main production site, where the vehicles are fully assembled inside Megabay 1 and 2. Once they've passed final checks, the Starship upper stage and the Super Heavy booster are laid down horizontally on a special support frame. Basically, it's a giant steel cradle that spreads the load and protects the structure. Now, these things are massive, over 70 meters tall when standing, and yes, they could technically be moved upright. But laying them flat makes it much easier to load them onto the watership, something SpaceX has never actually done before with Starship. The whole move can take several hours, with engineers keeping a close eye on everything to make sure nothing gets damaged. From there, the vehicle is rolled onto a multi-axle transporter with an air suspension system to absorb shocks. Then it's driven a few kilometers out to Boca Chica Beach. That route goes along Boca Chica Boulevard, the only two-lane road connecting Brownsville to Starbase. So, to keep everything safe, SpaceX works with Cameron County and the Texas Department of Transportation to temporarily shut down Highway 4 and the beach. Depending on the weather and schedule, that closure can last anywhere from a few hours to a full day. Once they reach the beach, Starship and Super Heavy are lifted by massive mobile cranes onto "You'll Thank Me Later," just like Elon Musk hinted recently. And here's an interesting detail. SpaceX actually planned for this ahead of time. That's why they removed one of the Super Heavy's grid fins. Without it, the booster can lie flat without anything sticking out or needing to fold against the body. From the Texas coast to the waters off Cape Canaveral, the trip usually takes around 7 to 11 days, depending on the weather. When the watership arrives, it docks at Port Canaveral, the main seaport next to Kennedy Space Center and Cape Canaveral Space Force Station. The port already has deep-water berths and heavy-lift cranes that regularly handle rocket hardware coming in from Texas. There, Starship or Super Heavy is offloaded, placed on a multi-axle transporter, and driven about 30 miles to the new Gigabay near LC-39A. Just like in Texas, roads will be closed temporarily to ensure safety. Once on site, the vehicle goes through engine installation, static fire, and launch prep, all streamlined for quick reuse, with the FAA approving up to 44 launches per year. Now, you might wonder, why not just move Starship upright from Texas? After all, SpaceX often transports Starships vertically for static fire and cryo tests at Starbase. Meanwhile, Falcon 9, also about 70 meters tall, is almost always moved horizontally after landing on a drone ship. If they did it vertically, they wouldn't need cranes to flip the rocket back and forth, and the watership could even carry more vehicles in one trip. But here's where things get complicated. Yes, SpaceX has plenty of experience moving Starship and Super Heavy vertically, but only inside Starbase. Those are short trips on private roads, perfectly flat, with no power lines, overpasses, or trees in the way. That setup makes vertical transport possible when Starship needs to be raised for static fires or cryo tests. The trip from the production site to Boca Chica Beach, though, totally different story. State Highway 4 is a narrow two-lane road lined with power lines, signs, and trees. Starship's upper stage is about 50 meters tall, and Super Heavy is over 70 meters. That's way above the 4.3 to 5 meter clearance limits for most public roads. Even if SpaceX shut down the highway like they've done before, making enough overhead clearance would be nearly impossible without major work, like temporarily removing power lines or traffic signs. On top of that, moving something that tall means crawling at an extremely slow speed to avoid wobbling, which would extend road closures and disrupt the entire Brownsville community. And let's say somehow they did get it to the beach upright. Another problem pops up: stability. When standing tall, the center of gravity is extremely high, especially for the 200-ton Super Heavy. Even moderate crosswinds could push dangerously against the vehicle. By laying it flat, the center of gravity drops way down, making it far safer on the road, and later at sea. Securing the rocket horizontally on the watership is also much simpler, since it can be strapped down to flat support structures, the same way launch tower sections were shipped. Designing a cradle to hold something that is massive upright through waves and storms would be far more complicated. And remember, SpaceX already has years of experience shipping Falcon 9 boosters horizontally by barge. Starship is bigger, sure, and it doesn't have landing legs to help, but the principle is the same: just on a much larger scale. So, what do you think? Is horizontal transport the smarter choice, or should SpaceX eventually figure out a way to go vertical? Drop your thoughts in the comments below. Now, once the new Gigabay in Florida is fully up and running, you'll thank me later won't really be needed for shipping Starship anymore, which naturally raises another question. Could SpaceX actually repurpose the watership into a floating landing platform? And you know what? This idea might not be that far off. In fact, in the draft environmental impact statement, first released by the FAA in June 2024 and then updated again in August-September 2025, SpaceX specifically proposed that Starship Super Heavy operations from LEC-39A would include full recovery landings, not just for the Super Heavy booster, but also for the Starship upper stage. The plan allows up to 44 booster landings and 44 Starship landings every single year, either directly at LC-39A or out at sea on drone ships in the Atlantic. For comparison, Falcon 9 already relies heavily on drone ship landings from Port Canaveral, and SpaceX envisions a very similar balance of cost and efficiency for Starship. What's more, the FAA assessment notes that some recoveries could happen as far out as the Pacific or even the Indian Ocean. Nighttime landings are even preferred to minimize noise disruption for nearby communities. But these operations aren't without side effects. The FAA also flagged risks to civilian airspace, where flights out of Orlando, Tampa, or even Miami could face delays of up to 2 hours whenever a Starship is coming down. And of course, there's the environmental impact on coastal ecosystems to consider. Still, this isn't just theory. SpaceX has been building the necessary infrastructure at LC-39A since 2019. The drone ship option is baked into their long-term strategy, and if, you'll thank me later, ever gets converted, it could be one of the first platforms to make that vision real. So yeah, what once sounded impossible is now written into the official plan. Go SpaceX! The China space program is far more advanced than most people realize. Even Elon Musk, the man behind the world's biggest private space company, had to admit that China's space projects are impressive. And he's right. Many people might not see it, sometimes just because they don't like China. But the truth is, they're a stronger competitor to SpaceX than Blue Origin, ULA, or even Boeing. If we let our guard down, even for a moment, China could pull ahead, especially in the race to the moon. In recent weeks, China's secretive space program has announced several major milestones in its effort to land astronauts on the moon by 2030. The first achievement we have to talk about is their progress with the Lunar lunar lander. Lunar literally means embracing the moon. Work on this vehicle started back in the early 2020s, and now it's entering its first round of rigorous testing to check its systems, engines, and stability. That means it only took them about 5 years to get this far. That pace is nothing short of remarkable. And honestly, it's something Blue Origin should take notes from. They've spent 9 years developing the Blue Moon Mk1 lander, and yet they're still far behind China's progress. Looking at Lanyu's design, there's no doubt they drew heavy inspiration from NASA's Apollo lunar module. Here's a picture of the Chinese lander with an engineer standing next to it for scale. The proportions look familiar, although China has made some big changes to the propulsion system. Remember, the Apollo LM was basically 2 vehicles in one, a descent stage at the bottom for landing and an ascent stage on top for returning to orbit. In Apollo's case, the system worked as a complete package with both the lander and the command module, but in China's recent test, they only put the Lanyu lander through its paces. The Mengzhou command ship had already been tested back in June. That test was carried out by the China Manned Space Agency on August 6th, just outside Beijing. Look at that massive metal tower and the network of cables surrounding the vehicle. I think we can draw 2 conclusions from this. First, the cables ensure the lander doesn't accidentally crash during the test, and second, they allow engineers to simulate lunar gravity and atmospheric conditions. By suspending the vehicle with those huge cables, they can mimic the moon's weaker gravity, about 1/6 that of Earth. Essentially, the cable supported around 80% of the lander's weight while it fired its main engines and fine-tuned thrusters to land on a mock lunar surface with craters, and then take off again. It's a clever setup, and a very logical way to rehearse real moon landings here on Earth. Of course, a lunar lander is only one piece of the puzzle. To actually get it to the moon, you need a rocket powerful enough to carry it there. And that's where the Long March 10 comes in. So, the Long March 10, China's new generation crewed rocket, just had its first static fire on August 15th, 2025. This is a big deal for their lunar program, especially after the Mengzhou spacecraft did its zero-altitude escape test in June, and the Lanyu lander completed its full landing and ascent test earlier in August. During the test, all 7 YF-100K engines on the first stage fired simultaneously for about 30 seconds, enough to check that they work together properly under normal and high-power conditions, while collecting all the test data. The engines produced nearly 1,000 tons of thrust, making it China's biggest static fire so far. Of course, if we compare it globally, Long March 10 is still smaller than SpaceX's Super Heavy booster. Super Heavy fires 33 Raptor engines during a full-duration static fire, generating 3,600 to 4,500 tons of thrust, even when throttled down. At full power, it would hit roughly 7,590 tons. That's 7 times more than Long March 10. Compared to Falcon Heavy, it's still only about half as powerful. Now China really does things their own way. Sure, the Long March 10 has a 3-core setup, 1 central core, and 2 boosters, similar in appearance to Falcon Heavy, but it was built specifically for China's moon missions, with engines and structures tailored to their needs. And that's the thing, just copying the layout doesn't make you better. If you're only copying, how are you ever going to beat SpaceX? Not to mention NASA. Alright, so, let's play this out. Suppose all of their vehicles are fully operational and ready for an actual trip to the moon. What would that mission look like? Well, here's how it would go. The Mengzhou spacecraft acts as the command and service module. It launches from Earth on a Long March 10 rocket with the crew on board and carries them up to lunar orbit. Once there, Mengzhou docks with the Lanyu lander, which was launched separately on another Long March 10, so the astronauts can hop in and start their descent to the moon. Mengzhou sticks around in orbit, basically acting as the support hub for the whole mission. Lanyu, meanwhile, is purely a lunar lander. It's designed to take 2 astronauts and a small rover down to the surface for a short stay, anywhere from 6 to 14 days. Just like Apollo, it has 2 parts, a descent stage to land and an ascent stage to get back to orbit. It's not a habitat or a base, just the vehicle that gets you down and back up. Once they're on the surface, the rover gets deployed to help with exploration and science work. When the mission wraps up, Lanyu's ascent stage lifts off, leaving the descent stage behind and docks back with Mengzhou in orbit. The crew and all their samples transfer back into Mengzhou, and then Mengzhou heads home. The now empty ascent stage, it just stays in lunar orbit. Sounds a bit complicated, right? But honestly, it's really the same playbook NASA used over half a century ago with Apollo. And here's the thing, China is taking the technology they copied and using it to try and beat the original, so don't underestimate them. The milestones they've hit recently are serious, and they're becoming a real contender in the space race. Just look at their Tiangong space station. While China keeps pushing forward, the ISS is aging fast and reaching the end of its journey. It's set to be deorbited and broken apart around 2030. According to Chinese media, 2 astronauts recently conducted a spacewalk lasting 6.5 hours to add extra protective panels to the Tiangong space station. They had done a similar mission back in May, so this was essentially a follow-up. During the EVA, they also checked and maintained other equipment outside the station. And get this, they returned in perfect health, which really shows how impressive China's Phaetian suits are. These suits provide oxygen, regulate temperature, shield against radiation and space debris, and maintain proper pressure in the vacuum of space. The fact that the astronauts came back perfectly fine after such a long time outside proves the suits can handle extreme conditions, from 250 degrees Fahrenheit in direct sunlight to minus 250 degrees Fahrenheit in the shadows. Exactly what will be needed for future lunar missions. Alright, let's talk about Tiangong, China's space station. Right now, it only has 3 modules, quite a bit fewer than the ISS, which has 17. But don't let the smaller size fool you. Tiangong is still a serious contender in space. The core module, Tianhe, launched on April 28, 2021. Then came 2 science modules, Wentian on July 24, 2022, and Mengtian on October 31, 2022. Unlike the ISS, which is a huge international effort with the US, Russia, Europe, Japan, and Canada involved, Tiangong is being built by just one country, China, on a super ambitious timeline. And that's something we really need to pay attention to. The demand for experiments up there is growing fast. They're even looking into generating rocket fuel, oxygen, directly on the station, which means more space, more energy, and more capability are becoming essential. Looking ahead, China plans to expand Tiangong to 6 modules, doubling its internal volume. The first new piece is a multi-docking adapter with 6 ports, which will attach under the current Tianhe core. It's designed to mirror the arrangement of the existing 3 modules. So instead of today's T-shaped layout, the station will grow into a cross, or what some are calling a double T. This expansion will let China add more scientific experiment racks, support larger space experiments, and generally scale up operations on Tiangong. Another major upgrade that supports both the station and China's bigger space ambitions is a reusable crewed spacecraft. Previously known as the next-generation crewed spacecraft, Mengzhou, which we talked about earlier, is modular, can carry up to 7 astronauts, and comes in 2 versions, similar to SpaceX's Dragon. One for low Earth orbit missions like trips to Tiangong, and a deep space version designed specifically for lunar missions. Adding Wentian and Mengtian really boosted Tiangong's scientific capabilities. The Tianhe core itself is 16.6 meters long and has a docking hub that can welcome both Shenzhou crewed ships and Tianzhou cargo vehicles, basically like a high-tech orbital hotel. To help move heavy equipment, there's a large robotic arm, key for positioning the Wentian and Mengtian science modules. It also assists astronauts during spacewalks. Compared to China's earlier experimental labs, Tiangong 1 and 2, Tianhe is a serious upgrade. Not only is it bigger, it weighs nearly 3 times as much, 22 tons. The space it provides could even host other countries once the ISS retires. China has said they're open to international cooperation, even with the US. But of course that's a bit ironic, since the US previously blocked China from joining the ISS, imposing strict restrictions under the Wolf Amendment. And that's partly why China is so determined to surpass us. But let's be real, SpaceX is standing in the way of China actually reaching that dream. First, let's talk about the space race. NASA Administrator Sean Duffy had a private meeting last month with the SpaceX HLS team, including Chief Operating Officer Gwynne Shotwell, to see if SpaceX was really on track. And luckily what he saw convinced him that NASA's $4.04 billion investment in SpaceX's HLS project was totally worth it. Talking to the press, Duffy said with a smile, "I spoke with the leadership yesterday, and they seem very confident about Starship. As long as we agree the lander is on track, they feel really good. They also said that if there's any delay with Artemis 3, it won't be on them. So that means SpaceX is gearing up carefully for Artemis 3, aiming to get humans back on the moon by 2027, just 2 years from now. There's really no room for China to overtake them." Now, let's compare. China's Lanyu can land about 26,000 kilograms on the moon, which is already an improvement over Apollo's LM at 10,330 kilograms. Not bad, right? But Starship HLS? It can deliver up to 100,000 kilograms to the lunar surface. That's massive. It's not just astronauts. It can carry science gear, rovers, habitat modules, even supplies to start building a future Artemis base camp. With its powerful Raptor engines and advanced elevator systems, Starship HLS lets astronauts do multiple EVAs over the week, with plenty of living space and, of course, full reusability. This design doesn't just meet NASA's Artemis requirements. It opens the door to long-term missions, like building a permanent base or supporting SpaceX's bolder plans, like Moonbase Alpha. So, yeah, Lanyu is a big step for China, but Starship HLS? It's a whole different league. Massive payload, crazy flexibility, and reusability that's shaping the future of lunar exploration. After all that, do you still think China really has what it takes to put serious pressure on us in the space race? I'd love to hear what you think. Thanks for watching. It seems like SpaceX really knows how to keep its fans hooked, constantly rolling out major updates to the most powerful vehicle in the world, Starship. Last month, they introduced a brand new upgrade for Super Heavy, featuring a massive component almost the size of an entire Falcon 9, the fuel transfer tube. Think of it like an auxiliary fuel tank that helps regulate the flow of propellant to all 33 Raptor engines without interruption. And this month, in fact, just yesterday, they publicly shared images of an entirely new, incredibly impressive grid fin design. Take a look at this picture. The first thing that hits you is the appearance. As SpaceX put it, the redesigned grid fins are 50% larger and higher strength. And they're not kidding. Just look at how small that engineer appears standing on one of these fins. The new design is nearly twice the size of the old grid fins used on Super Heavy version 2, which measured about 4.9 meters by 2.4 meters, a surface area of more than 11 square meters. That means the new fins are estimated to have an area of around 20 to 25 square meters, thanks to their increased length and width. Of course, it's a bit tricky to measure just from photos. On version 2, the fins looked like clean-cut squares, but the new ones are no longer perfectly square. The two right-angle corners have been trimmed, making them resemble a giant waffle. This size increase naturally means more weight. If the old ones weighed around 3 tons each, the new design could be pushing 5 tons. But judging from their sleek, polished look, SpaceX may have switched to a stronger alloy, capable of withstanding the higher aerodynamic forces that come with a larger surface area. Notice the pointed tips at the bottom of the new grid fins? Those are key to reducing drag as the fins move through the atmosphere, even with the increased size. They also improve directional control by optimizing airflow around the fin. That's not all. Those tips help generate lift and precise torque, allowing the booster's orientation to be finely adjusted during landing. Alongside these tips, you can also spot a series of wave-shaped ridges and grooves built into the base structure. These aren't just for looks. They act like reinforcement ribs, spreading aerodynamic loads more evenly across the fin and making the whole thing stronger without adding too much weight. And here's another thing. Newly released images show the catch point mounted directly beneath the grid fin, close to its central axis. SpaceX says these new fins will also be used for lifting and catching the vehicle, which helps explain why they're now built so much tougher. The catch point itself looks like a large pin with a hole through it, extending slightly beyond the thickness of the grid fin, so it can directly interact with the landing rails on Mechazilla's arms. Interestingly, some observers have noted that this design is similar to the catch points used on Starship itself. That makes sense when you consider that SpaceX's 2 orbital launch towers, Pad 1 and Pad 2, have different catching setups. Pad 1 has arms optimized for Super Heavy, while Pad 2 is tuned for catching the ship. By tweaking the catch point design, Super Heavy becomes more versatile and can land on either tower. However, the pin on Super Heavy will be slightly longer to ensure compatibility with Pad 1's hardware. Truth is, we're still not done talking about these new grid fins. As SpaceX added, moving lower reduces the heat they receive from Starship's engines at hot staging and places the fin shaft, actuator, and fixed structure inside the booster's main fuel tank. Basically, SpaceX is moving the grid fins a bit lower than before. Now, the fin shaft, actuator, and fixed structure sit right inside the booster's main fuel tank. That way, they can take advantage of the freezing cold fuel, we're talking liquid methane here, to help keep things cool. At the same time, they stay protected from the brutal conditions up near the common dome when Starship's 6 Raptor engines fire during hot staging. Dropping them lower also means they're not getting blasted as hard by that exhaust. And this change ties right into another upgrade, a brand new hot staging ring. It's taller, and it's got bigger vent holes to let the gas escape more efficiently. The trade-off? If the fins stayed where they were before, all that extra exhaust would hammer them. So SpaceX will drop them down about a meter, and that should solve the issue. Next up, here's something you might already know. Booster version 3 will only have 3 grid fins, arranged asymmetrically at 90 degrees, and 180 degrees. The catch points will be mounted on the 2 side fins that are opposite each other, while the center fin will have none. This means the fin shown in SpaceX's image is very likely one of the 2 side fins that will connect directly with the chopsticks during landing. Sounds strange, right? I mean, they've cut it down to 3 fins, and they're not arranged symmetrically. But don't get it wrong, in this new setup, each fin isn't just doing one job. They help control both pitch and yaw at the same time. Say the rocket needs to pitch up. 2 fins sitting 90 degrees apart tilt together to generate lift, while the third fin at 180 degrees steps in to balance things out or give a little extra push. It's a more coordinated dance, but it still works. For yaw, turning left or right, same story. The fins move in sync, each contributing part of the force. Even roll control, spinning the booster along its axis, can still be done by turning all three fins in the same direction. No symmetry, no problem. You just need smarter software to keep it all in tune. And that's before we even talk about the weight savings. Dropping one fin cuts a massive chunk of mass. Based on SpaceX's design, each fin weighs about 3 tons, almost 20 times heavier than a Falcon 9 fin. Removing one fin but slightly increasing the size of the others adds a bit of weight, but not significantly. You could still save around a ton, and that might seem small, but think about it. Shaving off a ton helps reduce stress on the launch tower during landing. That's the price you pay for handling Super Heavy's insane size and brutal re-entry forces. Shedding that weight means less work for the Raptors on ascent, and less stress on Mechazilla when catching it on the way down. Pretty smart move. Interestingly, Super Heavy's grid fins will still stick to an old-school approach, welded stainless steel alloy. Falcon 9's fins evolved from aluminum to titanium, but here, SpaceX is going with 304 stainless. Why stainless? It's 15 to 20 times cheaper than titanium. At today's prices, 3 tons of stainless steel run about $10,000. Mass producing like SpaceX, that can drop to $7,000 to $8,000 per fin. Here's the kicker. Elon Musk wants to build 1,000 Starships a year. That's 4,000 fins annually. Remove one per booster, and you instantly cut production time and save millions. It's also faster to build. Stainless can be welded, no complex forging like titanium. Plus, it laughs at heat. 301 grade steel holds its strength up to around 1,550 degrees Fahrenheit, compared to just 625 degrees Fahrenheit for grade 5 titanium. Of course, all of this is still on paper for now. SpaceX has run the numbers and studied past flights before locking in this design, but we'll have to wait and see how Super Heavy really performs with just 3 upgraded fins. So let's cheer on SpaceX, drop a "Go SpaceX" in the comments, and help push them closer to that first flight. Here's what's next at Starbase. The first flight of Super Heavy version 3 is expected later this year or early 2026, likely using Booster 18. Built from the ground up for all the Block 3 upgrades, its main structure is done, the fuel transfer tube is in place, and the common dome already has the hot staging ring welded. Full assembly could be finished by the end of October, depending on McGregor tests and Raptor 3 production. Booster 18 will mark a major step into the V3 era, and things are looking even brighter for SpaceX beyond just the hardware, especially after former President Donald Trump just made a move nobody saw coming. Here's the latest. On Wednesday, Trump signed an executive order telling government agencies to either cut out or speed up environmental reviews for commercial launch and re-entry permits. Now, the FAA, that's the Federal Aviation Administration under the Department of Transportation, is the agency that issues these permits. Their job? Make sure launches and re-entries follow environmental laws, align with U.S. interests, and don't put the public at risk. Cutting back these rules? Big news for companies like SpaceX. Led by Elon Musk, yes, a former Trump ally, SpaceX handles nearly all FAA-approved commercial launches and re-entries anyway. Dig a little deeper, and Trump specifically ordered Transportation Secretary Sean Duffy, the new acting head of NASA, to use all available authority to eliminate or speed up environmental reviews for launch and re-entry permits. White House officials noted that Duffy should still consult with the chair of the council on environmental quality and follow existing law while rolling back regulations. The order also tells Duffy to review, revise, or scrap a bunch of launch safety rules from Trump's first term. FAA tried new regulations back in 2021, but space companies complained they were too complex and slowed down the permit process. And there's more. Trump also directed NASA, the military, and the Department of Transportation to cut overlapping reviews for spaceport development, especially at federally owned sites like Cape Canaveral in Florida, Vandenberg in California, and Wallops Island in Virginia. That's basically SpaceX's backyard. On top of that, the Trump administration plans to put a political head in charge of the FAA's Office of Commercial Space Transportation, the office that issues launch and re-entry permits, and promote it to a more prominent role in the Department of Commerce. Duffy is also set to bring in a regulatory rollback advisor for commercial space. Here's where it gets wild. Just a few months ago, Musk and Trump had a very public fallout over a spending bill. There was a heated dispute, a rift between two former allies. Musk, who spent millions supporting Trump's 2024 campaign, even talked about starting a third party after leaving his advisory role at the Department of Government Effectiveness, DOGE. Yet, Trump's latest executive order on August 13, 2025, seems to directly benefit SpaceX. Is it strategic or just a staged move to boost SpaceX and other private space companies without looking like favoritism? Of course, this hasn't gone unnoticed. Environmental groups like the Center for Biodiversity called it a reckless executive order, warning that loosening regulations could put the environment and public safety at risk. Still, SpaceX leads in launch numbers and holds major contracts with NASA and the Department of Defense. This order gives them a serious competitive edge. Could this be SpaceX's golden moment? Only time will tell. For now, Elon Musk is in prime position to seize this opportunity and push his space ambitions toward Mars and beyond. On the flip side, even with Trump's backing, the state of California continues to give Elon Musk a hard time following SpaceX's move of its headquarters to Texas. On Thursday, California regulators rejected a U.S. military proposal to increase the number of SpaceX launches from a base in Southern California amid an ongoing lawsuit from CEO Elon Musk related to a previous vote. Members of the California Coastal Commission voted unanimously against the U.S. Space Force's request to boost SpaceX launches from Vandenberg Space Force Base from 50 to 100 per year.